Entity framework.
Hot chocolate.
Azure Cosmos. Entity framework. Power tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Chris Lanson.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Here we go again. Yep, we're back with another .NET Data Community Stand-Up. It seems like only yesterday that we did the last one, but just Shay and I this week. Jeremy's off doing some big data-y thing, I don't know. So we're having to push the buttons and be producers as well, which if we go off air, then it's because we just don't know what we're doing. So, good stuff. Anyway, yeah, so greetings to everyone. At least I've seen some comments there. Yeah, we've got someone from South Africa, because for a moment there I was like, no comments. Are we not going live? If we weren't actually going live, we'd have no idea what to do to troubleshoot it. So hopefully people can see it. Okay, so this week we're going to talk about interceptors. So Shay thinks I'm overly obsessed with interceptors, but I hope to convince him by the end of this session that they're actually really cool and he should be obsessed with them too. But we'll see if that happens. Anyway, so we're adding a bunch of new interceptors in EF7, and I've been figuring out things to do with them today, and I've got some, I think, pretty nice examples. So we'll get into that a little bit. First, let's just do a quick state of the unicorn. I'm sure people are aware that EF7 Preview 6 is out. It was up on NuGet yesterday. There's a bunch of the stuff that we're going to show today. The Materialization Interception, for example, is in Preview 6. Some of the things that I'm going to show today have been updated post Preview 6. So if you want to get all the latest, then do the daily builds, which there's instructions for on the GitHub repo, and it's super easy. But some of it, a lot of it is in Preview 6. So if you just want to try it on a public preview, then you can do so. Faster model building using proxies. We talked about this when it went into the dailies. previously, if you were using proxies, we generated the proxy types eagerly up front when you were building the model, which was very slow in some cases. We now do it lazily, so your startup time when using proxies is much faster. And they now also work with compiled models. So if you have a big model with proxies, you can use a compiled model and get lazy proxies, and that is much faster, like 2 orders of magnitude sometimes. So we have an identity resolution interceptor, which I was going to show today, but I can't come up with any example for it, which isn't just better served by doing it differently, so you don't need identity resolution. So I'm going to keep working on that and try and come up with something for the docs. But as of today, we don't have an example of that today. I ran out of time before I could come up with anything decent. So basically what that does is if you've got an entity, let's say you've got a product and it has ID 5, and then you try and attach another product and it's the same product, it has ID 5 too, EF throws an exception. By default, this actually will then call an interceptor and say, you've got this instance, you've got this instance, what you want to do, and you can copy values over or discard one or the other, so that you can actually move forward and kind of resolve that. Usually it's best to not get into that situation, so yes. But if you do, we also have something that seems pretty small, but actually a lot of people are waiting for, and that's the ability to map properties to different column names when you're doing some kind of one entity to multiple tables. So you've got one property, and then you go into multiple tables. And for example, the primary key is a single property in your entity, but might have different column names in the different tables. This actually comes up quite commonly on some of the older types of database schemas you might be mapping to. And so Andrew's done support for that, and that's in Preview 6 as well. Entity splitting is coming. We're hoping to get it into Preview 7, but we'll see. It's kind of down to the line there. And then Shay wrote a big blog post on save changes and the perf improvement that we probably won't talk about it too much right now. I'll just let me see if I can find where I had it open here. Here we go. Let me drag that over. So here it is on the .NET blog. So we already did a stand-up on this. So, go look at that stand-up if you haven't already, or if you prefer, then read the word round trip instead of hearing it many times. We now internally have a drinking game where whenever Shai's presenting, we just take a drink every time he says round trip.
Yeah. Thanks for all that marketing, Arthur.
Yeah, so lots and lots of great details here about how save changes works and the improvements we're doing in 7 for that. So there's that. There's the link. It's also in the show links. At least Jeremy said it was going to be. And we have a survey out about how people use databases in the cloud, which kinds they use, and why they use them, what the perceived benefits they have for those databases are. So whether you use Cosmos or Azure SQL or something completely different. So there's a link there. Again, that's in the show link. We also tweeted about this. A few people, I put a tweet out where I said anybody who retweeted my tweet would get a shout out on the next community stand-up. So I'm not going to try and say everybody's names, but these are the people who retweeted. So thank you to all of these people. Somebody's dad there. A lot of representation from all over the world, which is always awesome to see on these things. So yes, all of these people retweeted. So thank you very much for doing that. If you haven't taken the survey, it's literally less than 5 minutes. It's like 5-6 questions or something like that. And we want to use it to know how we can do better and what we should focus on and what it is that you really need. So do please try and do that survey. Okay, so that's the end of the state of
one more
debug
thing
show.
that one more thing that went in, a lot of stuff that went into Preview 6 is there's a lot of stuff there about aggregate functions. I just want to mention it. So the full thing isn't really in. It's already in for Preview 7. So Preview 7 will have all that stuff, lots of new functionality around aggregate functions. But a lot of the infrastructure already went into preview 6. So I'm just doing this to whet people's appetites. In a month, you're going to have a really nice preview to play around with a lot of function translations. And we'll probably do a talk about all that as well.
Yes, be good. Okay, so let's go on to interception. So I'm gonna share my other screen now. Maybe make that a little bit bigger. There you go, 30. That's pretty good, right? Okay, so what do I have here? So I did well, a few of us did a learn module for a session on the learn module for entity framework, which involved writing an API controller, an API endpoint, or whatever you call it, for this theoretical pizza shop, which I always think of as Costco Pizza, even though it isn't. So I've taken that basically as a basis for what we're going to do today. Certainly go look at the learn module. You can build this yourself easily. I'll also put it on my GitHub, the finished thing, so you can download and look at that. But I'll just go quickly through this just so people can see what it is. So this is a web API. We're adding a DB context and we're using SQLite, and I've got sensitive data logging on so we can see parameter values and such like. And then we're going to use Swagger to interact with it. So, and then I just have a thing at the beginning here, which is clean it up and get it into a consistent state at the start every time, including putting in some pizzas and saving that. So every time we run, we'll just be in a nice consistent state for each of the things we do. The way this works, you know, as we saw in the program here, the main, we're using DI. So we've got our DB context as a service, and we also have pizza service as the thing that is kind of, it's a, I don't know what you call, maybe, not sure what you call that, but basically the thing that is backing our controllers. So in the controllers here, we inject the pizza service, and we go into how all this works in the learn module if you're interested. And then we have just some things like get all, get by ID, create, add topping, all of that stuff. I also created a toppings controller, so so we also have pizzas and toppings here. And then in the, let's go and look at the service. So in the service, this is where we inject the context and have basically the methods to do these things, whether it's the create, update, and delete stuff, or just doing the queries. So this is all pretty basic, straightforward stuff, but go look at the learn module if you want to know more. And we just have 3 simple entity types, pizza, sauce, and topping. So feel free to ask questions. You know, Shay will answer questions. We'll also pull them up on here or save them for later and bring them back, but we definitely want to answer your questions. So if I run this, it opens up in Swagger, which I can pull over here. Just make that a bit bigger. And so we can do things like get all of the pizzas, and we get the pizzas back, or we can say, let's delete a pizza, try it out, put in
I have to say,
one.
I still find this magical, like how
It is, I know.
It's really magical.
And we get things saying back we deleted a pizza, and if we run this one again, let's see, execute this again, we should see, hopefully, maybe I have to clear this and then execute. We should see the pizza being deleted, but I don't see that. Maybe I have to. I'm not an expert at Swagger, so it's still there. Okay, maybe somebody can explain that. Oh, maybe I didn't hit execute on here. So that's the case. No, because now it's anyway. My demonstrating that it works didn't work, but hopefully it will work better in the things that I've actually tried, as opposed to just winging it while I'm talking. So, so what we're going to do? Let me bring up my cheat sheet here on the other screen if I can. Let me find it. Because I've been putting this together today, and if I remember all this, it'll be amazing. Okay, so we're going to look at materialization interception, which is when EF creates entities, like entity instances, and populates them with data from the database. And we're going to look at a few things from that. But the first we're going to look at is something you might want if you want to put services into your entity. So why would you do that? Well, before we get directly into that, let's go look at pizza. So pizza has a source property, right? This is the source that's on it. And if we look at where that's used in the services here, we have a thing which says update the source. So we're just using it like a simple kind of POCO object, almost like a DTO. We're just sending the source. Well, let's say we want to encapsulate that business behavior. Now, there's not much business behavior to encapsulate here, but that's because this is, just to keep it simple. What we could do here is make the setter private. So you can't just from anywhere set it. You have to call this method, right? So now we'll just call a method to update the source. Obviously, we now got to go update this code here to say, instead of just setting the source, we say update source. So now, basically just does the same thing as it did before, right? So we haven't really added any value there. But now we have this place where we could say, okay, we want to do something. Let's say we want to actually log what happens when we update the source. Now you could say, well, maybe the logging should go somewhere else. Maybe it should go in the controller, or it should go in the service, or whatever. And that's probably true. But for the sake of argument, we're going to say we actually got some business stuff in here that's significant enough that we want to actually log from the entity. Well, that's great, but how do we get a logger into our entity? And that's where EF can help you. So what I'm going to do is I'm going to add a property to the pizza entity, type iLogger. So iLogger is the kind of generic logging mechanism that .NET uses, that ASP.NET Core in particular uses. When you run this application, let me run it again so you can see that. If we're not looking at the Swagger, but instead of looking the application output, what we see is that all of this logging info is coming out. And I didn't actually do anything to really make that happen, right? It happened because in DI, where I say add DB context, this is hooking into the logging mechanism that ASP.NET Core application is already setting up. And so I get automatically the logging coming out there. So that's really cool. But what we want to do now is use that functionality, but actually in our entity types. So let me stop this and go back to the pizza. So I've got a logger property, and we can put some code in there to use it. Find it here. Okay, so copy that. So in my update source method, let's say we're updating the source on the pizza with this name from this source to this source. Okay, but of course nothing setting logger at the moment. In fact, it's telling me it's never used set method. So how do we get around that? Well, that's where we can use the interceptor. So we can say, whenever EF creates an instance of this pizza, I want you to call back into my code, and then I can do something to set the logger. So let's go look at our context here. Context is very simple, just some configuration, nothing else. And down here, I'm just going to say, okay, now let's create a materialization interceptor. So that's defined by, I have to get the namespace in there. That's defined by this new interface, materialization interceptor. And this has a bunch of methods in it. all of which have used the interface default method. So you don't actually have to implement anything, the ones that you're not using in here. So no need for the abstract base types with the abstract virtuals or anything anymore. But it has 4 methods. It has creating instance. This gets called before EF has even created an instance of your object. And this gives you a chance, we'll actually use this later, it gives you a chance to change, to tell EF, don't create the instance, use this instance instead, which is really useful. And that's an important point about interceptors. Interceptors not only give you a hook into the behavior of EF, but they let you say, actually, I want to replace that bit of behavior that you're going to do, in this case creating an instance, with my own. And that's really powerful. And that's what makes them more powerful than kind of just events or other things. Shay?
Yeah, it's maybe worth mentioning. So EF obviously already has a lot of interceptors.
Yeah.
It's had them for a long time, and this philosophy is also present there. So there's always a before and after kind of thing, and the before thing can actually allow you to bypass the whole thing. So if you take a look at there's a database execution, like a command execution interceptor, for example. If under certain circumstances you have the power to say, oh, I'm looking at this SQL and I have some something there, some comment which tells me that this is special. And instead of actually executing that SQL against a database, you can go and get it from some memory or some web request or whatever, and you're completely bypassing the whole database command. And then you hand back EF a result, and it's gonna continue that flow. So it's pretty powerful. You can. It's not, as Arthur just said, this is not just about events. It's not about knowing when things happen. It's about overriding the behavior completely.
Absolutely. I'm seeing somebody say, never put a logger inside a domain object. Scary. Yeah, I mean, this is really to show you the kinds of things that you can do. And to be fair, scary or not, over the years, I've had a lot of people ask, how can I do this? How can I put a logger into my domain object? So, your mileage may vary, as they say. Okay, so as Shay says, so there's a before and after. So there's also get called after we've created the instance. You've got it back. You can actually replace it with a different one if you want. There's also initializing instance and initialize instance. So this is called around the constructor. So you call a constructor, and you get an instance back. But typically, not all of the properties have been initialized at that point. These get called before and after the property values are initialized. So, the name of the pizza and so forth. Unless, as is in the case of the pizza, you're actually calling a constructor, and then obviously we can't intercept between, like, in the middle of this. So these will be set before initializing is called. But that's there's a more advanced mechanism called constructor binding that I'm not going to show today that lets you even get into more detail about how you change this and build expression trees around the whole thing. We're not going to do that today. It's important to note, though, that navigations are not set before the initialized instance is called, and that's because of the mechanism. There's a chicken and egg situation there around. Well, we create that instance and track it, and then we load another one, and then we set its navigation. So people will ask, oh, I just want to know when everything's done. Well, when is everything done? Could be when you complete the query, but that's a whole nother level. So this is about setting the properties of a particular instance and not its navigations. Okay. So so what we're going to do in this case is just do on the initialized instance, because all we care about is we've done everything, but I want to set the logger property in it. And let's find my bag of code here. Oh yeah, and I had a note. Don't forget to add the interceptor to the context. So we've talked about this before, but I could add the interceptor in where I'm doing add DB context. So here, but that's kind of clumsy in some respects. I want the interceptor actually to be co-located with the context. And so this is where using both the on configuring and the add DB context together is actually very nice. So I can overload on configuring here, and then I can say add interceptors and just create a new instance of my interceptor there. And then this will be called however my context is created, whatever add DB context, whatever provider is done, this will always get created. And let's make it an expression body because it looks nicer. Okay, so I've taken note of my note to forget to add it. And now let's put some code in it. So the typical thing you do in an interceptor that doesn't do anything is you just return the instance. So this basically, if you return a different instance, then effectively what you're doing is saying, throw away that thing that you already created and use this new one instead. We're not actually going to change that, but what we are going to do is say, if this is a pizza, then use DB context as a service provider, because you can do that, and get the logger factory that we use for doing our logging. And then from that, create a logger factory, and we'll give it a category of Costco. I always call it Costco Pizza. I know it isn't, but I'm going to do that. Costco Pizza, and set the logger in there. Okay, so basically now when we've created this, we'll set a logger factory. And then when we go back to our pizza and we update a source, we should see logging come out. So let's try it. Okay, so running again. Just going to open my Swagger. Hopefully it goes better than last time. Okay, so let's do update source. So try it out. Let's take pizza 1 and set it to source 2. See what happens. Okay, so it says it was successful. Let's go back and look at the output to see what happened in the console here. So we can see that indeed we got an info level message from Costco Pizza saying updating source for meat lovers from nothing. I guess it didn't have a source before, to Alfredo, which I should say now, there's a theme of British cuisine here where we do terrible things to pizzas, just horrendous things. We'll get to the confused pineapple pizza a bit later.
There's a confused pineapple pizza. Okay.
There is, yes.
Now I've learned something.
And then we did in fact update it in the database as well. So we've got a logger inside our application. It's a bit dodgy in some respects when you look at the Interceptor, because it's basically saying, if it's a pizza, then I know pizzas are special and have loggers, right? So let's do that. But really, you would want to do something like take this and let's see, what can I did this earlier. I'll just do it from here. Where's my refactor? Okay. Distract an interface out of this. Let's call it I has logger, and we'll give it the iLogger in there. So we've got a logger in there. So now anything that is I has logger can have this behavior. So we could, for instance, easily put it on our source and add the not map property to that too, and then use it in there. Not going to add any logging, just showing what I mean. And then when we go back to the Materialization Interceptor, nope, not that one. It's in here, isn't it? So our logger injection interceptor, instead of saying if it's pizza, we just say if it's a I has logger and call logger. There we go. Now we can log to anything that has a logger. So now we injected any entity that has an I has logger can do logging. Shay, go.
There's a good question in the audience here. So does this mean that if we have like a lot of inserts, do we get the same logger 100 times or different loggers?
Good question.
I know what I would answer. What do you think? I mean, I would, if I wrote this, so this is obviously just a sample, but we could create the logger once, like in the, and then obviously, or cache it, and then just hand over the same logger every single time, right? But this is just a demo, so you guys should be.
So I have an admission to make. I find that the whole iLogger factory and iLogger abstractions to be incredibly confusing, and I can never remember what you're supposed to do with what or how you're supposed to create these or any of that stuff. I looked inside the EF code to see when we have an iLogger factory, what do we do with it? And we call create logger, and we get and I did that, but I hadn't even thought about whether you need to cache it or not. So that's a really good point. You probably do, but
yeah. I happen to also do a lot of logging on NPG SQL recently, and yes, you definitely want to create your loggers once. So you have one logger with a given category, Contasso Pizza in this case, and then you just reuse it. That's basically how it works.
Okay, so that's the first one. So let's move on to whatever's next. Let me look on my cheat sheet here. Generalize, we did that. Okay. Concurrency exceptions. So everybody loves DB update concurrency exception, right? Except sometimes we don't. Sometimes we're like, why is it giving me a concurrency exception there? It's not useful. It isn't helping me. Let's see here. Let me get my Explorer. No, I'm sorry. What I want to do is go into the pizza service. Let's actually we maybe start running this again. I think it will shut down. Now, when we go into deleting a pizza, okay, so let's say I want to delete pizza 1. So I can say delete pizza 1, and when I execute that, what's going to happen? Well, it's actually, if we go look at the code.
Careful, there's the 500 error there.
Oh.
That we saw before. There's some foreign key thing because it has a dependent, right?
Interesting. Oh, I know what that was. I changed that thinking, yeah, that won't matter, will it? But it does. Yeah, interesting. Okay, so we fix that. Let's fix that.
Live debugging.
Yeah. So I think what happened is that in the service, where are we? Oh, I'm already in the service, that's why I can't find it. We're doing find async here, and I added this. I added this. Oh no, it's not that, because this is doing. Maybe it's. Oh no, maybe it's not here. It's in the actual controller. It's get by ID. So what I did is I separated get by ID into one that just gives you back the pizza and one that gives you back the pizza with all of its sauce and toppings, because I didn't want to be using that everywhere. And in this case, we need to get them both back because there's no cascade. The database isn't doing cascade delete, and so we need to actually get back the dependent object so that when we delete the pizza, the foreign key constraint won't violate, and instead we'll delete the things that it's dependent on. Hopefully, that's what it is. So let's try that again. Okay, waiting for my Swagger to come up. So let's try delete pizza, try it out. 1, execute. Nope. What foreign key constraint is it saying is failing here?
Now you can see EF's engineering manager try to debug some foreign key issues live on the internet.
Yeah. I don't know.
Should I do a dance and entertain our crowd?
Yeah.
I actually thought of an interesting thing you can do with this interceptor, because I'm obviously always perf obsessed. So the one where, so for example, you know how every time we materialize, we obviously instantiate a new instance of pizza, right? That's what materialization does. But if we really were, obsessed with perf and wanted to reduce the allocations, we could have some sort of pool for pizzas and use the interceptor to get instances out of that pool. For example, right? This is something that this unlocks if we wanted to do it, as long as the user somehow returns that thing into that pool. And then our interceptor, every time, instead of having EF instantiate, instances which then need to be garbage collected,
Yes.
the interceptor would, get instances from a pool and then hand them over to the user, who would put them back into the pool once they're done with it. So just some ideas.
Well, it's interesting you say that, because we're going to do something similar to that.
Oh, okay. Yeah.
It's
sorry.
not the actual pool, but just a cache of immutable objects, which is
Yeah.
easier.
Very cool. Yeah.
Yes. Yes.
Very cool.
I don't know. I don't know why this is not working. Let me revert. Let me go to here. Let me just go back to. I wonder if it's.
I'll talk in the meantime.
Yes.
So go ahead and debug. I'll discuss this. So there's this question of using interceptors for audit logging, which is one very, very typical case where you want to use interceptors. The thing is, so there's a wealth of interceptors at this point in EF Core, and I guess the tricky question becomes at what level you want to intercept, because there's various options. You can intercept at the SQL level. That's been around for quite a long time. And in many cases, that's what you want to do. This, what you've seen here is materialization, right? So that's what happens when we query out things from the database. I don't know if that's where you want to do audit logging, right? For example, any changes, like when you do save changes, that doesn't materialize anything, because you're changing something in the database, right? So you wouldn't get that in your audit logs if you audit at that point. So you have to, I think the trick really becomes, EF is a very big and complicated beast. And the question is knowing, all these interception points you have and choosing the right one. I'm saying this specifically because this comment says create, update, delete. And obviously materialization is not the thing for create, update, delete. It's the thing for queries. So I'm not sure that would be the right one. But good comment.
No idea what is going on here. This bar's all working. Let me delete the database files. See, I'm getting desperate now.
Oops, sorry.
Oh! Could be
Arthur
that.
had his eureka moment.
Could be that. Yes. So topping. Let me put back in. I wonder if it's still in here. If I go back, let me put that in. See if this works. I think it was creating a required relationship. It shouldn't have been, but let's see. Live TV, right?
Mm-hmm.
Okay. Try. I always forget I have to press try it out.
I want to add one more thing to add to that audit question.
Yay!
Oh, cool. Arthur found this bug.
Got it deleted. Okay.
If you want to, by the way, so if you want to audit, then keep in mind there's interceptors, but there's also events. EF has a lot of extensibility. Auditing is a case where you don't really need to change EF's behavior at all, right? The point with interceptors many times is that you want to intercept in order to modify the behavior in some way. If all you want to know is be informed when something happens, maybe events are the thing you want more. So maybe for auditing, events would be a little bit, at least conceptually, more the right tool for the task. But take a look. There's very ample documentation in the EF docs. Take a look at that. You have that overview of all the different events and interceptors that you want. Obviously not these ones, because they're very new and we haven't documented them yet. Back to you, Arthur.
Yeah, so I'm going to leave this. We're going to pretend that this isn't here for now, for later on when I say that this object is immutable, which it isn't anymore. But hopefully, maybe we'll remove it at that bit when it doesn't matter anymore. Okay, but let's go back to delete. Okay, so looking at the delete code, which we've now actually scrolled through quite a few times. So in the controller, what we do for delete, which is, you can argue best practices and everything, but we ask, does the thing with the ID exist or not? And then if it does exist, then we delete it. Otherwise, we return not found, right? So basically what that means is if you try and delete something that doesn't exist, we'll just say not found. Okay. And then in the delete thing, it's like we'll look it up again, which probably don't really need to. But anyway, then we set it to deleted and call save changes. So this is all fine. But there's a race condition here, right? If two people come in and they both say, they both want to delete the same pizza, okay, then they could both find it. First one gets into here. Execution gets broken here. The second one comes in. It deletes this. The second one comes back here. Now it tries to delete it, and you end up with trying to delete the same thing twice. I could do that with, thread sleeps and running two things at the same time, but we can get exactly the same behavior by just saying every time we, just basically write a bug. Every time we try and delete it, let's try and delete it twice, and we'll see what happens. And this time I expect to get an error when I try and delete it, right? And we'll see what that is. Okay, so go into pizzas, try and delete it. One, execute that, and bang. And this time we said database affected 1 rows but affected 0. Why? Well, this is the
exception.
famous DB update concurrency exception, right? Because this time we tried to delete it, it didn't exist anymore. That pizza wasn't there, and so it just said it doesn't exist. You've done something. We had a big discussion in the team about when it's actually useful to know that delete didn't work, as opposed to just say, oh, fine, it's not there. I tried to delete, it was not there. I got what I wanted at the end anyway, so who cares, right?
Right. As opposed to update. Yeah,
as opposed to update where you probably want to know more. So this is actually a reasonable case where I'd say, actually, if I'm doing this, let's just ignore the DB update concurrency exception. Well, we have an interceptor for that now. So let me go and do that. Let me find my. So we've actually had save changes interceptor for a while, and this is a new couple of methods on the save changes interceptor. Let me go to my context here. Add this. Okay. Bring in all the usings for that stuff. So save changes interceptor. We now have throwing concurrency exception. There isn't a before and after in this case, because once it's thrown, there's nothing we can do, it's gone. However, there are async and non-async versions. That everything in my web API is async, so I'm only overriding the async version. The reason we give you some things like in this one, there wasn't an async in materialization. There isn't an async thing because there's no database, not in an async path, right? There's no database operations going on. When you're doing a concurrent exception, it is plausible that you might want to go and log something to a different table. So you might or do some kind of asynchronous operation. So in that case, we give you the async context to do that. So in this case, I'm overriding the throwing concurrency exception async because I'm calling save changes async, and then we get a bunch of event data. So this is another thing about interceptors. You often get these things called event data, which gives you information about these things. So in this case, it gives you the entries that were involved in the save changes operation that failed. So what we can do is let's update this with some actual code to look at the entries. So this is pretty trivial, and another thing about interceptors is they often can be simple if you know you have a constrained environment, like you know what you're doing. So in this case, I'm saying anytime all the entries in the save are deleted, I know that's my delete operation, so that's what I'm going to intercept. It gets more and more complex if you try to differentiate lots of different cases, right? But take advantage of what you know about your domain to make it simple. Maybe not this simple, but do what makes sense. Don't over-engineer it. And then we're doing one of these things that Shay was mentioning earlier, where we can say, oh, let's not do it. What we're basically saying in this case, see, we've got this interception result. If you call interception result suppress and return that, in this case as a value task, it tells EF, don't do that. In this case, don't throw that exception. Just continue like that didn't happen. So essentially ignore the fact that the rows affected check only returns 0 instead of 1. And then I probably do have a note here because I made it everywhere. Like, don't forget to add the interceptor to the DB console.
It's grayed out. That makes me nervous.
Yeah, exactly. I should
Your
have
ID
noticed.
is
yeah. So this is a params thing here. So you suppress. Should just let it format for me. But anyway, yeah. So this is a params thing. You can add multiple interceptors here. So now it's not grayed out. We're going to add that one as well. Okay. So let's run that and just see what happens. I've still got my double delete in. So hopefully the second delete will now. We won't see it do anything. So let's go to delete. Just forget to press, try it out. Execute. And indeed now it was success. So basically, if two people, in our real scenario, if two people had done it exactly the same time and the race condition kicked in there, the second one did nothing, we say we don't care. It's gone anyway, we don't care. So
interesting.
Can
I use this just to talk about something else we're delivering in EF Core, like very quickly?
Indeed.
So EF Core also will have, so we don't have this in yet, but it's still in the plan for 7.0. We have the bulk update feature. So what you're seeing here, in order to delete something, we're selecting it out of the database, and then we're using EF's change tracker API. We tell EF that it's going to be deleted, and then we persist that back using save changes. That's the traditional way that you do things in EF Core with a unit of work, mindset and so on. However, starting with EF7, you should be able to express an arbitrary SQL update query, right? So you would be able to use link to say, find all of the pizzas where the ID is something, delete them. So to express an arbitrary SQL update, which is something that EF doesn't support today. It's important to say. Once you do this in EF7, that would be perfect for here. You would be able to simply, instead of loading that thing and then persisting back the change to delete, you would be able to simply send a single update to the database and delete it. You will get back the rows affected, by the way, via that API. And if you care about it, whether you had a concurrency thing or not, then it's up to you if you want to raise an exception or an error, but you don't have to. You will be able to consult the rows affected and do something or not. And the reason you would want to do this, as opposed to what we just saw, is of course round trips. That's the thing that I knew I would say this at some point, but it is more efficient to simply send a single update to the database rather than do a select, update, EF's internal change tracker state and all that kind of stuff, and then persist that back to the database. You're better off just sending a single update, to the database.
Yes.
So that's what I wanted to say.
So there's a comment here. Isn't it better to fix the race condition? This feels like ignoring a code smell. Well, how exactly would you fix that race condition? It's not as trivial as it seems. And in fact, that's the reason optimistic concurrency is often the preferred method of dealing with it, because in order to fix the race condition, you basically have to lock. Essentially, you have to say, while I'm doing this whole thing, don't let anybody else do it. And that's inefficient and has other issues, in fact, and can cause deadlocks even for all the common cases. Because what are the chances that two people are actually going to do this? And so optimistic concurrency is basically, let's be optimistic about this. It's not going to happen. But if it does, then let's step back and resolve it. So typically in an optimistic concurrency, you can just ignore, but often what you'll do is say, hey, like, two conflicting changes have come into the database for an update, for example. Somebody's trying to change it to this, somebody else is trying to change it to that. What do you want to do? Resolve it, and then some interaction happens, and that's actually a very kind of pragmatic and efficient way of dealing with concurrency that can happen without trying to force it to never happen. In this case, we're saying the way we resolve this is just say, oh, well, if it's gone, then it's gone, so we don't actually have to do anything.
Yeah. Again, delete is kind of a special case. It's arguable whether we even care about concurrency exceptions and delete, because the end result is the same. It's mostly interested in update scenarios, the whole thing with
Yes.
concurrency. But anyway.
So let's move on to intercepting expression, the expressions in a query tree, which is something Very tasty. Lots of people like to do that. So we had this. So before we go into it, let's set up the scenario here. So let's say when I'm getting all my pizzas, I actually want them to be in an order, which I think is a fairly reasonable thing. So I'm saying order them by name, okay? All my toppings, order my toppings by name. But in fact, name is not guaranteed to be a unique property, right? So theoretically, somebody could create 3 pizzas all with the same name, and when we now have a non-deterministic ordering, and this causes problems if you're doing paging, for example. We did a stand-up on paging, so go back and look at that. But you can kind of see the general issue. The database is not can return them in a different order each time it runs the query. So the first page might have some things that are duplicated in the second page and missing, or vice versa, right? So really, whenever you're doing ordering, you want to have a deterministic ordering, okay? And often a way to do that is just to add a secondary ordering by something that you know is unique. So in this case, we can say then order by the ID, right? So but primarily order by the name, but then by the ID.
It's just important to say that that's the right way in general to deal with it. And Arthur, I think, is going to show something that is not necessarily a recommendation. This is actually
see whether you want to do it this way or not. Anyway, okay, so what we're going to do though is we're going to say, right, if we're going to do that everywhere, developers don't like to do it everywhere and repeat themselves, right? They'll want to put it in one place. So can we just say every time we're ordering something, let's put then by at the end by the primary key, which we know is unique. And let's assume that, because as I was saying before, about your domain, how your entities are. So let's assume our entities that have integer primary keys and they're called ID. In fact, we'll before we get to that, let's actually add some data into the database so we can kind of see a bit what's happening. So I'm going to go to my initializer, and this is where we're going to say just confused pineapple pizza. Okay, there's 3 of them, and they all have the same name because they're very confusing. And it's a pizza which has this is not the Hawaiian pizza, which is actually quite good. Hawaiian is like tomato sauce and mozzarella and ham or Canadian bacon and pineapple, right? This is an Alfredo sauce and pineapple, which is British cuisine at its best. Really bad idea. And we're adding 3 of them, so we've got 3 confused pineapples now in the database. Now, this is one of those things that gives us an opportunity to remind people that there is no default ordering, right? Because, of course, when we go get this, when we go get our pizzas here, try it out, execute, what we're going to see is actually the confused pineapples come up in PK order already, because that's what the database happens to be doing here for small amounts of data that you haven't done things with. This is often what happens, but there is no guarantee that will happen, and at some point your data will end up not coming back in PK order, and this will be a mixed up list, right?
In fact, there's the 2 right below. This isn't PK order, is it?
No, because I'm ordering by
name, by the name. Oh, sorry. Okay, I see. I missed that. Yeah, that makes sense.
But even so, right, it still holds, right?
There's
no
SQL,
secondary ordering
in
by
the
primary
SQL
key
world. No ordering is ever implied unless you specify it explicitly. It's very simple.
Right.
You want ordering, you have to order by. That's how it is. So
what we're going to do for the rest of the example is actually reverse this and order by descending primary key, just so that we can see that we've actually changed something in the output. It doesn't really matter, right? It's just giving a well-defined order, but just so we can see that we changed something, we're going to order by the reverse primary key. Okay, so we've added our confused pineapple pizzas. Let's do another one of those extracting an interface, so we kind of codified a bit more what these things are that we're going to order. So basically what I want to do here is introduce an interface that says anything that has an integer primary key on it called ID. We're not going to call it iPizza. Yeah, I has key. I never get to use I has interfaces in real code because it never passes the API reviews, but in these I can call them I has all the time. Okay, so yeah, so our pizza is I has key, and in fact our topping is also going to be I has key, and just for the sake of consistency or source. So all of these things have the key. So now anything that implements I has key, we know has that integer ID property. Cool. Okay, so let me go back to my cheat sheet here. We've introduced confused pineapples. We've generalized to anything. Okay, so we're going to add expression visitor. Okay. Let's go back to my context. And down here, I need to finish that. Bring in some namespaces, and then it's grayed out. So remember, we have to add it here. Okay, so the I expression query interceptor in the build that I'm using, it has 3 methods. The team convinced me that these 2 should be removed. However, we're going to use one of them later, so we'll see if that changes that. But for the time being, what we're going to do is get the link expression tree that comes from query, and right before EF does anything, we're going to process it. We're going to do stuff to it. So, and then we're going to return that expression tree as a different thing. So whenever you're working with expression trees, generally the way to do that is through the visitor pattern. So the visitor pattern is a double dispatch mechanism that just gives you methods that you can overload in your visitor for all the different types of expressions. So you call visit on the query tree with our visitor, and then it's going to say, it's going to call a method. So I could override here, for example, let me show you. So I could override visit constant, or go to, if we had go to expression, member, new, all of these things have their own methods, so that you can say, all I care is that when I see a particular type of expression, I want to do something to it. In this case, what we want to do is we want to do something whenever we see the order by method, right? Whenever there's a call to the order by method, let me find my code again. I've lost it here. Okay, here. So I'm going to copy and paste this big chunk of code in, and this is probably why Shai's like, do you really want to do this? But I'll walk through it relatively quickly. Okay.
Expression tree manipulation is not
Yes.
for the
So this is all as before. We have a visitor. So in the visitor, we're visiting a method call expression. So in the expression tree, when we get a method call expression, if that method is on queryable, which is where the link extension methods hold is kept, and it's called order by. This is a very simple check. Sometimes you might want to do a better check to make sure it's really the order by that you're looking for. This can be a good way to introduce bugs, but I'm trying to keep this simple. Excuse me. Then we say, okay, well, it is a method call expression. Let's get its generic argument. So is it a method call expression for something, this type? So this might be pizza. Is pizza an I has key? So pizza, sauce, topping are all I has key. If it is, right, keep going. If not, it's not the method call we're looking for. Okay, so we now know it's an order by for one of these things, and order bys have a lambda expression in them, right? You go back and you look at the pizza service where we're doing order by. This is the lambda expression saying I want to order by name. Okay, so we're extracting that out of there. It's actually it's quoted. I don't really know why it's quoted, but it's quoted in the expression tree. I'm sure Smith could tell us. So we get the lambda expression out of there, and then we get the parameter for that. So the parameter for that in this case is the entity type, right? The thing that's being passed in, the E here. Okay, so we've got information out of it. Now what we're going to do is, instead of just returning that method call, we're going to wrap that whole thing with a call to then by. So in this, remember I said I was going to do descending. So we're actually looking for, so this is the method then by ascending with two parameters, right? So we found the method info, the metadata information for then by. We're going to say call that, call it with the same queryable type, the same entity type that we had before. In this case, we know the return type for then by. This thing is going to be int, because we know that I has key is about having an integer key that we're going to use, so we don't have to dynamically do anything there. We pass as the body to this the method call expression, so we're passing in the order by to this. This all looks backwards from the way procedural programmers are used to looking at things. You know, think back to your functional programming where, you know, you're wrapping things in there. So it's like, so we're actually wrapping the order by with the then by, so that the order by happens, and then the result of that gets passed to the then by, right? And now we create a new lambda, which is essentially now the lambda for the then by, which says, okay, the type of it is a func of the entity type to int, which is the type of the key. We get the name of the property for on the entity type, and we pass that into lambda. So what we've done here was basically built the equivalent of doing this. And by descending, E goes to E, E goes to E ID. So we built that and inserted that into the expression tree, right? That's perfectly clear, right? Easy. It's not easy. I'll show you a trick though. We'll run this in the debugger, and we will stop it here, which is where we know we're at the thing that we're going to do. Actually, no. That's probably the wrong place, but I'll do it here anyway. So let's go and do. Sorry, I've got Swagger on the other screen here. I'm just going to say, give me all of the pizzas. We should hit that breakpoint. Okay, so use the debugger and look at the lambda expression that link created for you, right? So in this case, we've got this method call expression. This is what link created for me. And we can see in here, you can look at the debug views, but that can be a little bit confusing. Most importantly, you can see, for example, that we've got a urinary expression. This is the quoted thing. And inside here, there's an operand, and this is the lambda expression. So we can see here that this is the type of this is a lambda expression. And inside here, it's got parameters, so the parameter expression, you know, with the name E. So basically use this as your guide for what you need to call here to build it, right? That's because otherwise you'll get confused. I mean, maybe you won't, but I do. So that's my hint for trying to do these. Look at what link provides for you and basically try and copy and adapt it, and you'll still get it wrong loads of times. So it's just keep iterating on it. Okay, so we don't have the then by in, just checking that. So let's actually see this in action now. Okay, so let me pull the Swagger over here. We're gonna ask for all the pizzas. Okay, so remember we've done them in reverse order, so they were previously 4, 5, 6, they're now 6, 5, 4. And even more proof that this did what we expected is the SQL that was generated has order by name, then by ID descending. And further, if we go back here and this is, why people want to do it, right, is because when they get all their toppings, they want the same thing to happen. So if I've done this right, then when we get the toppings back, let's go look here. We can see toppings also has been rewritten to have order by descending. So we've had a generic mechanism that's added a order by descending on whatever IHAS key thing that we order by. It's not going to work for complex cases where you've got subqueries, you're doing projections, you're doing all that stuff, right? But it does work it can be useful for a lot of cases. A lot of times you don't have that. You have some simple things and you have a simple, consistent shape, whatever that shape may be. You recognize it in your expression visitor, you modify it, and you return it. And that's it. So cool.
Can
you
I
have
say a
anything
word or
to
two?
say about that? Yeah.
Yeah,
I thought
I'm
you might
actually, I'm a fan. So maybe people have been tracking my facial expressions, and you may have seen some skepticism. I'm actually a fan of this feature, where I thought this really, really makes a lot of sense. Some people want to integrate a third-party solution which does various expression tree manipulation before EF Core, does its thing. We've received multiple requests like this, like some package out there that knows how to get an expression tree and do some sort of transformation like what we've seen, but basically it does it as a black box. And people have been asking, how can I integrate this thing into all of my queries consistently rather than doing it every single time I do a query? And this is exactly this. This allows you to integrate that kind of thing. So at the very start of, before EF Core does anything, it basically allows you to do arbitrary changes to your query tree, and that's awesome. I do, however, really, really recommend proceeding with lots of caution. So manipulating expression trees like this is notoriously hard. You have to have a lot of deep understanding on how the query tree looks like, what kind of manipulations are legal. The moment you get something wrong here, the query will be illegal and EF will bomb, and your queries will not work. And it's also very easy to get something that works in some common case, but then when you start getting into the details, it doesn't work at all, right? Like Arthur just mentioned. For example, the thing that you just saw will not work on subqueries, because in subqueries, the order by that you have inside the lambdas is not an iQueryable, it's actually an enumerable. So anyway, there's lots of tiny details that I would really, really recommend. This is an amazing tool, but it's a shotgun. And if you go into this, it's an Uzi, exactly. Be very careful with an Uzi in your hands, right? It can allow you to perform amazing things, not the Uzi, this thing, but you can also really, really hurt yourself with this. So I would really say use this a little bit as a last resort, and only if you're sure you have a good understanding of how expression trees work.
Yeah,
I still think, Arthur, at some point we have to do like an internal talk about the query pipeline and really talk about how the visitors look like, and some challenges around that. That would be cool.
Yeah, but I don't understand all that, so you'll have to do that.
Or we get Smith over here.
Or we get Smith, yeah. Okay, so we're going to take a step. I know we're over time, but that's traditional. We're going to take a step back to materialization now and kind of come back to something that Shay mentioned. So what we're going to do is say, okay, if I have a bunch of immutable data, immutable entities that never change, and they're used in lots of places, then why don't we cache those and reuse them rather than constantly creating new instances all the time? I'm going to use, for this example, I'm going to use toppings for that. Now, not a great example, like countries, for example, is a good example. There are good, but we're just going to assume that the toppings don't change, they're immutable. You might add new toppings, you might delete toppings, but they're immutable. Sorry, go ahead, Chad.
Arthur, I'm sorry. Can I just say one more thing about the last thing? There was actually a good comment here.
Yeah.
So I want to show this. So a person in the audience asked, we have query filters which add a where clause globally to everything, right? So why not do the same for order by? Right.
Yeah.
And that's kind of like what you did just now. You did something that's a little bit like a query filter, but for order by. So I mean, we could of course add a feature like this to EF Core, but I think there's very good reasons why we would not do this. So filters query filters work very nicely in cases which are very global. Like you never
Yes.
want to show deleted records, right? Or in multi-tenant apps, you want to filter out, you want to filter in only things for your current tenant. So the scenarios are very global and easy. Whereas with ordering tends to change inside the same application. So if your user, you have a UI, your user typically can change the ordering, right? They want to do it ascending, descending via this field, via that field. So it's not ordering as opposed to filtering is not something that's amenable to doing at a global level in your application. And I think this is also why this approach, even with the interceptor, could have its limits as well. So yes, you could detect in the order by that there's already an order by there. So this only adds a clause in the order by. It adds another column in the order by. It doesn't create the order by itself, which we could also write that. But do you really want to reason about that in a global way in your application? I'm not sure.
The reason I did this, actually, I was going to do filtering, and I thought, if I just put a where clause in, then that's just global query filters. Why am I even showing it?
Right.
And then also because we had somebody ask a question about, well, they were saying is my ordering isn't deterministic. What do I do about it? And the answer is, well, you order on the primary key. But to what Shay is saying there, it's so much easier to do this, right? To add it in here. Now,
it's not,
and even then, you can abstract this out. So at your application layer where you're generating your code, you can abstract that out and say, whenever I'm doing an IHAS key thing and I'm ordering, then call this thing and it'll put a then by. And it's so much easier than trying to intercept the expression tree and recognize the place and all that. So don't make things more difficult just because it's cooler.
Exactly. Also, I personally like that my queries, when I look at the source code, I can see the link, and the link corresponds to the SQL. So what this does is it creates magic under the hood. You're not seeing that order by clause, but it's that ordering, but it is there. It's added by some magical thing behind the scenes. And good luck understanding that. And in a year's time, when some other dev looks at your code, they don't understand where that ordering comes from. So I would advise against this kind of implicit, very implicit thing.
Right. Okay. So let's cache our toppings. So I'm creating another Materialization Interceptor, and I've added it to the list here. Notice that I've already got the logging's also Materializations Interceptor. You can add multiple to the list here. That's fine. You don't have to combine everything. We under the codes we create a composite if we see this, and everything works fine. So you can add multiple interceptors that implement the same interfaces. In fact, as we'll see later, you can have interface 2 interceptor interfaces on the same interface on the same interceptor as well. Okay, so what we're going to do is we're going to look at creating instance, because in this case, remember we said, actually, what if we don't want EF to create the instance? What if we want to replace it with something that we've already got? And so, Shay had mentioned a cache and putting things, a pool and putting things back in the pool, which is good, but to keep it simpler. Instead, what we're going to do here is basically just create a dictionary, because these are immutable objects, so we can share them. We're relying on the idea that we can share these objects. I'm going to play with fire here and go back and remove this again, so we know delete won't work, but that just makes sure that these are immutable, right? Nothing in here can change. With this navigation property in there, we're going to put the pizzas that are associated with a particular topping instance, and that could mess things up. So this is an immutable, right? Pizza still has a reference to topping, but there's no back reference. Okay, and we're going to use a concurrent dictionary because multiple threads can be coming in here, right? And from multiple requests and accessing this thing. So we have to be thread safe here. So that's our cache. And then it's pretty simple stuff here to actually look up in the cache. So remember that we had the this materialization data, this event data. I think we're going to change the name of this before we release. But so in this case, this has some really useful things in it. Perhaps rather than look at the API, we'll just look at the usage here. In particular, it's got these methods get property value. Okay. Two of them. There's one that returns an objects instance, and there's a generic one. What these do is they go into the internal buffer that query is using to get property values of the entity that will be materialized before it's materialized. The reason there's a generic and a non-generic, well, the non-generic is there so that you can dynamically do things. Like you don't know what type the property you're looking for is. You just want to get anything. But if you know that it's actually going to be an int, like we do in this case, then using the generic one means that we can go directly into the data reader and get the int out of the data reader without ever boxing it. So if you can use the generic one, use the generic one because it avoids boxing it. And that's one of the main things about our query pipeline that really, helps with perf and stops with having excessive garbage collection, is that when we read simple values, intrinsics, out of the data reader, we never box them. They never get boxed before they go into your entity. So this allows you to basically retain that kind of functionality when you're doing interception, which I happen to think is pretty cool. And definitely you could not do this in EF6. Okay, so what we've done is we've said, give me the ID value of topping. Actually, we've already generalized this, right? Because I was going to just do it for toppings first and then do generalization later. But let me come back. Let's just do it for toppings right now because it's easier to see. Oh no, we didn't generalize this one. Never mind. I don't even know where I'm going here. That was the other one we generalized. Okay, so if this is a topping, then let's look in our cache. If it's in the cache, then we call suppressed with result, which is the same as we saw before for suppression, but in this case, you're saying actually use this topping value that I've got from the task, return that. And what that will mean is that EF won't go ahead and create the instance, it'll just use the one from the cache. So that's great, but we also need to be able to add things to the cache, right? So let's do that. And we could, in fact, anytime we've got the instance created, any of these methods where we have the instance created will work for this because it's a reference type. So if we do it before the property values are set, they'll just be set afterwards and so on and so forth. But we're going to do it right at the end and make sure we've got the fully initialized object. And we're going to say if it's not in the cache, then try add it to the cache. So then we're going to basically get it out of the cache if it's in it, and if it's not in the cache, we're going to put it in the cache. Okay, so this should work, and what we should be able to see is it's hard to see this working. I should have run it in the debugger. Let me stop and run it in the debugger. That would be easier for us to see. Okay, so let's put a breakpoint on here so that we can see when we're going into the cache and when we're not. And let me run in the debugger again. Okay, once the Swagger comes up, I'll bring it over here. Let's get a pizza. So we'll get pizza 1. Nope, go ahead, press that button. Get pizza 1. Okay, okay, so when we get a pizza, we're getting its toppings as well. So let's actually move the breakpoint here, it'll be easier. So it's saying, okay, give us, sorry, let me move this up. Give us topping 1. Is it in the cache? No, it isn't. Therefore, just return this, which is a non-suppressed result, which means EF is going to create it. And if we put it down here, it would be put in the cache. Likewise, topping 2 right now is not in there. Okay, so we've done that. Let's get back to our Swagger. So one thing to note about this cache, I should have mentioned this earlier. So this is kind of like a second level cache, right? Because EF is all when you have a context instance and you do a tracking query, EF is already caching those things in the context as a tracking query. This is static. This is app domain wide for my entire application. So even if I create a new context instance, this cache is still going to be used. Further, it's going to be used for no tracking queries. It's immutable data, so we don't care. So this is a different level of cache from just using the context. So for example, if we now go and do a completely new context instance, so let's go down to, okay, just get all the toppings, right? So try it out. There's no parameters. Execute that. So we're back in here. So topping ID 4, don't have that, right? Topping ID 3, we don't have that. Topping ID 1, oh look, it's in the cache, even though it was in a different context instance. So in this case, we're not going to get that from the database, and we're going to still create it. And likewise with 2, we do the same
Very
thing.
cool.
There.
Very cool.
Okay. So there's an obvious, well, perhaps not obvious, but there's a thing here that you should be saying yes, but. And perhaps if we, well, I'm not going to run out. I'm just going to say. So we're still going to the database for these things, right? And this is the same as an append-only semantics when you're getting things out. We go to the database to run the query, and then we say, okay, I've already created an instance. I already have in my cache an instance with that ID, so I don't need to materialize a new object. So we're not creating lots of garbage, but we're still going to the database, okay? But what about one of these places, such as here, where we're trying to add a topping, and all we want to do is find a topping? Do we even have to go to the database? Well, if it's in the context, we know that find doesn't go to the database. It just gets out of the cache, right? Can we do a similar thing with our second level cache where we bypass going to the database at all in this case? And the answer is yes, but possibly not after the team make me remove these other methods. So this is what we're going to, this is when I see what Shay says about this, because this is getting pretty crazy at this point. Okay, let me find my code here. Okay, found it. Okay. So let me stop here. In this same interceptor, I'm actually going to add a method that's part of expression tree interception. So remember how I was saying earlier, like you may want to actually implement multiple interceptors in the same place. Because in this case, I actually want to intercept queries at the same place where I have my cache. And we have this other method, the one that's slated for removal, which says, once you've compiled a query, once you've done all of that, and the result is a delegate, so we're not working with expression trees anymore, we're just working with a delegate, then give me that delegate. So if I want, I could replace it with a different delegate. Again, we're going to do some, we know what kinds of things we're doing in our application. So we're going to say, okay, well, if what we're getting out of this delegate, so let me run this, because then we'll actually be able to see what we get here. Okay, so running this, and let's go to add, I think it was add topping, right? So add topping. So to pizza 1, we're going to add topping 5, whatever that is. Okay, so we're now in here, and we're executing a query, right? And at the moment, this is a query from query context, which is the EF kind of internal information about the query, and then returning a task of pizza. Well, that's not the one I want, because I only want the thing that's returning the topping. So we're not going to do that one. So we're going to skip over that one and just keep going. Likewise for there. Now we have one that is returning a topping. So this is potentially the one I want. And in fact, if we go back here, we can see we're actually in the find anything for topping. So this is actually the one, but we'll do some further validation. Say, okay, let's go look in that query context, which has the parameters. I did that. Oh, it's because we're not in the delegate yet. Okay, so no, actually, so okay. At this point, we're not going to look at anything more because we're in the compilation stage, right? So we don't actually know a whole lot more at this point. But what we can do is we can now say, return a new delegate that does this stuff, or just executes the original delegate. The original delegate is what's going to query the database for the topping and return it, right? So I'm going to put a breakpoint in here now. There, I think. I don't know. Okay. Let's make this easier. I know we're running out of time, but let's just statement lambda, and then I can easily just say what I want to. I want to be in the delegate, right? I want a breakpoint in the delegate. Okay, so we've done that. Let's run again. We'll go to add a topping. Try it out. 1 and 5. Okay, so now we're actually in this delegate. So now we can actually look at the parameter values, right? So we have this C, which is a relational query context. Actually, it's down here as well. Let's just look it down here. This has a lot of stuff that, it's got stuff that we use. So it's got the loggers, it's got the context instances being used, a bunch of stuff. What it also has is the parameters that we're passing. If I can find parameter values, there we go. And in fact, inside here, we have one parameter. It's got a name that we've generated, based on the find thing. This is for find, so it's not a very nice name. And then the value 5. So we're saying, okay, we're looking for something with one parameter. We want it to be an int, and if it is, we're going to look in the cache. And if we find in the cache that topping with that ID, we're just going to return that topping directly without ever querying the database. Otherwise, we're going to run the query executor, right? So when we go over here, this time I stepped over, so but it's going to run the query executor, right? Because hopefully it should say here like count returns 1, values returned 1. Try get value returned false. So we didn't find it in the cache, right? If we go back here though and do this again, I don't know if it's going to work again. It might crash at the end, but hopefully it will still get into here. So at this point, we step over this again. Now try get value returned true. And we're just returning a task from result. We're not doing any database. No round trip, Shay. No round trip, right? We're just returning the value. So in fact, what we've done is we've done a simple kind of second level cache that when find, even if it doesn't find that immutable object in the context, it's now going to look in the second level cache and just give you that without ever hitting the database, which I think is pretty cool. Also quite dangerous, and a lot of things that could go wrong. And how do you know that this is the query
The right one,
and all of that kind of stuff? But I think we also had somebody asking us about how to do this a while ago. Like they wanted to do something like this, right? And so this is an approach that possibly could work, unless we just remove this exception point entirely.
So that's my question, Arthur. Am I correct? Is it possible to do this with a database interceptor? Exactly this thing?
Yes.
So there's actually no specific need to do this in the query pipeline, like in this phase of the query pipeline, right?
But if you do it in the database interceptor, then you're passing the SQL to figure out if it's what you're looking for, right?
Sure,
is
but
that
we
better?
have. Well, the thing is, so the parsing, this parsing is also not trivial, right? As you just said, you have to somehow identify. So you've got a query tree rather than a SQL, but it's still, I don't know how one identifies something from, it's a very complex task. What we usually advise people to do, like the same thing to do in general, is when you use a database interceptor, you add a query tag, right? There's this feature that we have.
Add a query tag to find.
That's true. Yeah, we have an issue for that. You're right. You're very, very right. But as long as you're doing a normal query, then this kind of thing is actually possible to do, right?
I mean, maybe you just do a normal query, because if you've already got a second level cache, you possibly don't care about the context cache as much anyway. So database interceptor is certainly a way to do this. I just love interceptors. Do you love interceptors, Shay?
I think I love them up to a point. Maybe not as much as you. No, I
Okay.
mean, what I do want to say is, I think these extension points are great. Some of them are not meant for a normal user, but rather as
Yes.
an interception point for a package for somebody who is like really thinking about this in a general way, so to speak, right? I mean, some of
Yes.
these are too complicated and too much of a
dangerous.
huge Uzi. Exactly, they're dangerous, and I wouldn't advise like just a dev to use them in their own thing. But I do think it's wonderful we have these extension points for packages, and it can, there could be a whole ecosystem now that sprouts up around these extension
Yes.
points. So I think it's
Indeed.
cool.
I just saw this comment come. I haven't been reading the comments. Why not hitting the cache just before the fine? That's easier. Yeah, so again, you could just put your own cache in your application level and not do any of this stuff, and that would probably be easier. So yeah, but powerful stuff if you're willing to take the risks, and if it's really worthwhile for you to put the time and investment into doing it. And like Shay says, is there can be packages that do this, extensions that do this, then useful. Do we have questions we should go to, Shay?
I think I managed to answer most of them. I'm not sure there's anything specific.
Okay. Cool. Well, this has been fun.
Yeah. Did some live debugging and
Yeah.
query tree manipulation. Always fun.
Yeah. No, it's sometimes the stuff that you're not supposed to use is the funnest to use. So Okay. Well, I guess we'll end there, and thanks everybody for joining. I'll read through the comments later. I always like to read through them later, even if I don't get a chance doing it while I go. And now I have to find that how I do that thank you screen that the producer always does for us. So. But what do we say? Oh, keep it sargeable, right? Always keep it sargeable, and we'll figure out what to do in 2 weeks and see you then. Thanks, everyone. Bye.